Hello students, this is Apratim Sir. Today we will try to explore on Newton's second law of motion. Newton's second law of motion is related to momentum. Momentum idea is given in the second law. Momentum means mass into velocity. Hello students, can you see it clearly? There is a bunch of books, and beside the bunch of book there is only one book. I try to push both of them, the bunch of the book and the single one. Now I try to push the bunch of the books. I am feeling some difficulty because their mass is higher. But when I move the smaller book or the lighter book, you can say, I feel easy to push the book. So students, today's topic is the mass of the heavier ball is m1 and the mass of the lighter ball is m2. First of all, we try to move m2 using m1. What happened? The m2 is moved by the ball m1. Now I will try to move m2 near the m1 so that we can move the m1 using m2. What happens? See, we are using m2 to move m1, but every time m2 gets distracted from m1, and here also it cannot move the m1. So this is our experiment that easily in case of m2, m1 can move m2. Okay, and when we try to move m1 using m2, what happens? You can see it clearly. We are trying to move m1 using m2, but every time the m2 is failing to do that. Every time you can see that. Every time it fails to move the m1. So students, we will now discuss the mathematical expression of Newton's second law. So first of all, you know that the Newton's second law is the change of momentum is proportional with the applied force, and the direction of the momentum is equal to the direction of the force applied. So I am doing the mathematical expression. Please look at to the whiteboard. So F vector is proportional with m into v vector, whereas F is the force applied and m into v vector is the momentum. So force applied is directly proportional to the momentum. Now applying differential calculus, F vector is equal to k into m into v vector. Now F vector is equal to k into m into d dt of v vector, vector is equal to k into m into d into v vector by dt. Here the rate of change of the velocity is denoted by d into v vector by dt, ddt of v vector, or a vector is equal to k into m into a vector. dv by dt is the rate of the change of the velocity. So you know the physics of the acceleration. That means the change of the velocity according to certain time is denoted by a, acceleration. So dv by dt is the change of the velocity according to time t. d by dt changes the rate of the velocity. So a vector is equal to k into m into a vector. Now if in both sides, if all are in unit, so unit means 1, all are 1, that time or a vector is equal to m into a vector. Here k is the constant and the value of k is 1. So a vector is equal to m into a vector. So this is the mathematical expression of Newton's second law. Now the applications of Newton's second law in brief. So there are some applications of Newton's second law.